So here's our probit. I'm going to switch this to probably what you had. Which is a penny increment. And again, a penny increment would probably be fine if we weren't doing if we had dollars instead of pennies per ounce. Yeah. Did you guys all use penny increments? You did? What'd you use?
I don't know, but it doesn't look like that.
Yeah, that looks choppy, doesn't it?
Yeah.
Yeah. So, and again, you're gonna get full credit, but don't do that again. It shouldn't be choppy. It should be. We just want to smooth out these. Take out the sander and smooth out these things. So again, our prices are really small. So I went to a tenth of a penny. So I'm just going to add a 0 and watch the difference. And that looks fine. And again, you could probably cut out that tail, but we're gonna need that tail for the stuff we're gonna need later. We're gonna actually be using that tail. So big difference. You gotta remember, one of the things, you gotta remember who your audience is. For a lot of these people, the analytics is gonna be way over their heads. It's gonna be stuff that they're not going to understand. But a lot of these people are marketing people. And marketing people know visuals. They know color schemes, they know what looks good, what doesn't look good. And if I don't know anything about logic or probit or probabilities or anything else, what I will say is, why is that curve so choppy? It'll literally bring a presentation to a halt. And never underestimate the pickiness of people that, for a living, put together marketing material. I could tell you one time, I don't know if I've told you this story before, but it's a horrible story because it just brings back memories. One time I used red and green on the same graph. And one of the marketing people, so told them never put red and green together. Well, I never heard that. Why?
There's whole books on colors and charts and things.
People.
So you guys have heard this before?
No.
It's terrible.
Oh, well, he's had heard it before. But yeah, she said, and then she started telling me why, because the brain, for some reason, can't distinguish between red and green, and it looked good to me. It looked nice. One was red, one was green. I could see the difference between red and green, but it literally turned into a 45-minute lesson on why you shouldn't have red and green on the same graphs. And she was coming from, it was a woman, and she was coming from, I think she had a psych background as well as a marketing background. And so she was giving me the marketing and the psychology and the human braininess of it. And it was one of those things where I've never done it before, so she got her point across. My point is those choppy lines, red and green, if we haven't heard that before, don't mix red and green, again, which I had never heard before. Those kinds of things will drive marketing people nuts, and it'll, like I said, it'll bring a presentation to just a standstill while you listen to why that you're not supposed to mix red and green. I don't remember the psychology of it, but I just remember the pain of it. So that's where that choppiness comes from. Reduce the increments. It's going to take you a little bit longer. If you look at the margins instead of, let's look at the first one. So for the one where I used a tenth of a penny, there's now 121 different prices, going from 0 to 15 cents in tenth of a penny increments. For the one where I used a penny, there was, is that it? Yeah, there's 13 different increments. So is this quicker than the 121? Yeah, but it's quicker by the blink of an eye. You're not going to notice the time difference all that much. So, you know, it's almost a costless improvement in the visual. And one of the things we're going to do is do this in Tableau. So we want the Tableau visuals. And the Tableau visuals are going to be based on the stuff we do in Stata. So the other thing is, and again, you did it exactly right. At least the last person did. Yeah, this one's chopped. Again, I don't know if it's the same one or not. But we're going to make use of margins. And what we want to be able to, and margins is super powerful. It does all these predictions for any range of prices. But for example, in this case, we wanted to compare the probit and the logit. And we've got them on top of each other, but I can't tell the difference. They're not, what we want to do is superimpose them on top of each other. And you can't do that in margins. You can only run one regression at a time. So we need to learn how to do that. We need to learn how to combine margins together. So that I want to take my probit, I want to take my logit, and I want to superimpose them, and I want a visual to see exactly what's the difference between these two things. Because I can't tell with that. So to do that, we're going to run this margins, all 121 of them, and we want to literally, these are the predictions, by the way. These are the predictions at the individual prices. So this isn't, this is the 65th price. Remember, the price goes from 0 to, was it 15 cents or 1.5 cents? 15 cents? Yeah, 15 cents. So these are the prices of, these represent the prices from 0 to 15 cents in 1/10 of a penny increments. And these are the probabilities, so they increase. So in essence, we can do this one of two ways. We can copy and paste this, which we don't want to do. Copy and pasting is never fun. Or we can use Axis. Okay, I got that. But we can either copy and paste this and regraph it, or in Excel or do something like that. But Stata actually has a function to save our margins out. So it'll save this output, and then we can run one for the logit, one for the probit. We can save the probit output predictions, and then we can combine those two files together, and then have one file that we can graph and kind of just slap on top of each other and show graphics. Because one of the, and we're going to do this later on, but we're going to do it with more stuff. So I think a good example of what we're going to be using is to compare, what we're going to be doing is to compare this logit and probit. So we're going to run, so we know how to use the margins function. So margins, post-regression, we run our regression. Here's our margins function, or I should correct it. Here's our margins function. The thing we're going to do differently is add that last saving part. Saving is going to save the margins. It's going to save that output. So everything that gets produced by margins, it's going to save, and it's going to create a new file wherever you want it. So I'm saving it, and then you got to tell it where to save it. I'm saving it in my 461 file. I'm calling it probit logit A, and I'm putting the DTA extension because that's a Stata data set. So adding that saves my file. Then I'm going to run my logit. I'm going to run that exact same margins, except I'm going to call this one probit logit B because I want to distinguish this one from the other one. Okay. I got my 10th of penny increments, and let's double check our graph, make sure it comes out right. Okay, we got that. So we still can't compare these two. So what we want to do now is just combine those two. So I want to find that file. What was it trying? Let's see. Oh, it's because of the replace. Oh, I know why. Because I changed that to an E instead of an F. Yeah, I use 3 computers with my laptop, this one, desktop at home, desktop in my office. All 3 of them, I use different drives. So the drives are almost always going to be wrong. Okay, so I created 2 files. One was called Probit Logit A, one was called Probit Logit B. Open A, so I'm just going to use that. Again, it's not, it's an E. And I've got a new file open. And this file is literally the output of the margins. And remember, in our margins, well, it's actually relatively self-explanatory. The underscore margin is the prediction, represents the predicted value. So you can see here it tells us it's the probability of choosing Heinz, and it tells you it's your predicted value. The other thing we want is, so that's our y-axis. The other thing we want is our x-axis, which is price. And price is not explicitly stated in here. Well, actually it is. It's here. But it's designated at underscore at 1. So underscore at 1 is our price, and then margins is our predicted probability from our probit. So what we want to do is just change those names, or at least change one of those names. So let's call underscore margins, let's call it probit, as in the output from our probit. So now we can see that underscore margins is gone. It's now called probit, and it's our predicted value from our probit. Fine. At 1, underscore at 1, we know is still our price. We also generated another file called Probit Logit B, and that was the output from our Logit. Now the reason I changed the name of this underscore margin is because in our other file, it's also going to have a variable called underscore margin, but it's going to be the prediction from the Logit. We don't want 2 variables with the same name unless we're going to merge by that variable. Does that make sense? So essentially what we're doing is we're taking 2 data sets. These are 2 data sets. Visuals always help. Visuals always help. We're taking 2 data sets and we're merging them together, but we need to merge them by something so they're aligned properly. That something that we're going to merge them by is price, because price is the same in both data sets. What's different in both data sets is one is predicted from a probit, one is predicted from a Logit. But they're both called underscore margin. So we just want to make sure we change those names because we don't want those to merge together. We want those to be separate. Does that make sense? That's kind of weird. The merging and appending stuff is always hard. But it's vital to what we're going to be doing. So we changed the name of underscore margin because the other data set has another variable called underscore margin, but it's different. It's the Logit prediction. This is the probit prediction. They both are going to have this at 1, and that's what we want to merge by. So we want to merge by all, 121 of those prices? We're going to merge by all 121 of those prices. So the data sets, we're not making it any longer, we're just making it a little bit wider. And it's going to be wider in terms of, we're going to add Logit, we're going to add the Logit output to this data set, or vice versa, this one again. And the command for merging is merge. And they actually changed merge. It used to be different. I cannot, but it's better now. Everything gets better. So, so what's the syntax? The syntax is that in both files, we have a variable called underscore at one, and those are our prices. So it's a one-to-one merge. We want to take the underscore at ones in one file, merge them with the underscore at ones in the other file, and we're going to merge by those 121 observations. So that's what this is. One-to-one, at one, using that other file. This is nice because this tells you how successful your merge was. And this tells us that we know we have 121 observations. All 121 of them merged correctly. So 3 is good. We had no variables for which we had no match. So 0 is good for not matched, and 121 is perfect for our match because that's how many observations we have. Now, if I describe this, we'll see that we still have our probit, but we should have another underscore merge. Again, it's the probability of choosing Hines, but this is the prediction from the logit. So now we have the output. We can rename that too, just for fun, because that's what we're all about. It's fun. Let's rename underscore match, and we can rename at one price Hines. And now we can do what we couldn't do before. Just do a scatter. Pretty close to the same. You know, what we said about the difference between the logit and the probit, and I think I probably mentioned this in the PowerPoint. I think it's in the PowerPoint. But I said the logit has fatter tails, and you can see that the logit, in fact, does have fatter tails, but the difference is infinitesimal. It's a little bit fatter here. It's a little bit fatter over there. But for all, for all useful purposes, there really isn't much of a difference between the predictions between logit and probit. I think I told you that the logit was developed in the days when computer time was expensive, and the logit ran quicker than the probit. So that's why the logit was developed anyway. So it was to save computer time when we had giant mainframes and they were in rooms like this with air conditioners and the lights dimmed when you ran a probit. That was really why logits were developed. So yeah, you're not going to get much of a difference between the logit and the probit. What we might use this for is, for example, let's say we ran a logit for, we'll be able to do this anyways, but let's say you had a logit for one region, and then a logit for another, and you wanted to compare the two. Again, you probably only run them using margins. You have to run them individually. So you'd have to save those so you can kind of compare. Well, how much different is, this is sales from, how much difference is sales from Safeway than Rayleigh's, or something like that? How much difference are those probabilities of purchasing our product at each of those stores? And that would be something that kind of a brand manager would ask, right? Is Safeway promoting our product more than Rayleigh's? Or is it promoting it more effectively? One of the projects I worked on in the wine industry was making sure that when I promoted a product, and I got to pay for this, when I promote a product, is the retailer actually doing the promotion? Or are they pocketing that money and not doing it? And that's a big problem. They actually have inspectors that will go to this, there's a firm that hires inspectors that go to firms and check to see, okay, I paid for a display on the store, and I paid for an end cap at the store. Is there an end cap? It's yes or no. If it's not there, then, and I paid for it, then now I'm mad and you owe me money. So one way to check it is to see how we're getting different results. If we're getting different results, we can kind of slap these two on top of each other and say, they look pretty close. it looks like Safeway and Rayleigh's are performing equally well. The likelihood of purchases at any price is roughly the same. It is virtually the same. Not roughly the same, it's virtually the same. So being able to take disparate data sets and combine them, we're going to be doing that a lot more of that. So again, saving the margins, add the save command. You're going to have these two different files. Open one, merge it with the other, and then we can save it under some merge name if we want to use it later on down the line. We're good. Any questions? This is one of the things that, and I think I mentioned this to you before, one of the criticisms I've gotten about you guys is you're good as long as the data set's ready to go, but, and it's not your fault, it's really my fault, because we don't spend a whole lot of time in database manipulation. The data has to be in the right form for you guys to do what you've been taught to do. If it's not in the right format, if you've got two different data sets and you need to combine them, we never covered that in this data, so how are you supposed to figure it out? Go through the manuals. So I want to add as much as that kind of stuff as possible. Plus, we're going to want to be able to, again, take this stuff and put it in a Tableau so we can make a dashboard. And we don't want to be doing copy and pasting, which is I think what we did in 580, copy and pasted. Yeah, we don't want to be doing copy and pasting, especially as the data sets get bigger and bigger. Like we had 121 observations here. It's not that big, but it's just, we shouldn't be copying and pasting. There's got to be better ways of doing this thing. And there is. So now we got a merge data set. And it comes with all the other stuff. So it's got the confidence intervals and all those things. Did I send you guys the Tableau link at any point in time? No? Okay, so I need to send you guys the Tableau link. All right. So let's go back to the original data set, which is that catch-up would be so interesting, isn't it? That's one of those things that you get fascinated by. This stuff. Or maybe not. Yeah, because I think I mentioned this last time. I know Heinz has kind of leveraged itself from the ketchup to the mustard business. So they infringed in French's territory, which French's I think had a similar market share that Heinz has. They're, you buy mustard, it's mostly French's. But Heinz kind of was trying to leverage its ketchup and saying, okay, now they're selling ketchup and mustard together now in bundled pairs, and saying, if you haven't seen the commercial, it says literally, if you love our ketchup, you'll love our mustard. It goes going to go well with the ketchup. So they're trying to infringe on Heinz's, French's mustard dominance. All right. Here's our data set. We have prices, and we have our promotional aspects. So we got this, again, this is still, was this Nielsen or IRI? I forgot. But we got the display for Heinz, and Hunt's feature for Heinz and Hunt's, and then feature and display for Heinz and Hunt's. So we can do what firms do, which is how effective are our promotional efforts. So that's all we want to do. We want to measure how effective we are at promoting. And when we had linear demand curves, we talked about price per unit, here's quantity, here's demand. We said promotion, the goal of promotion is to try to shift out that demand curve. So this is without, and this is with promotion. And we can measure that, this vertical distance as a promotional effect. It's kind of compounded by some other issues. We talked about prices and those things, but let's at least start with here. We can kind of start with this first measure of promotion. Are we able to shift those S-curves out over? So how effective are promotions at increasing the probability of actually buying this product? This isn't actually buying this product, this is buying more or less of it. But we're going to use the same kind of intuition to measure the effects of promotion. We just included a dummy here. Is that what we did? A shifter? It's a shifter, right? So it's a dummy, and that's basically what these are. So all these promotional aspects, except the price, obviously, all these promotional aspects are dummies. So we can see that. We just tab them. I'm going to tab all of them. I'm sure you'll believe me after the first one. Here's display Heinz, and it's a 0-1. It's been on display 447 times. It has not been on display 2,351 times. So Heinz was on display about, it looks like 16% of the time. And so on. So all these are dummies. We can include them in our regression just like we did in our other regressions. So let's see, regressions with one promotion. So here's a feature for Heinz. Remember this is a probit, so remember that the coefficients have not a very intuitive interpretation. We look at the sign and significance, downward sloping, significant, the law of demand holds, which the law of demand needs to hold. Promotion effect is positive and it's significant, so it's shifting out that, let's call it a demand curve. It's shifting out that demand curve, what's probabilistic or binary demand curve, it's shifting out that demand curve. So we're getting the expected results, which is good. It's what promotion is supposed to do. So let's graph it and see what it looks like. We're going to run our margins, and we're going to use this. It's like I changed the price to 12 cents, just to keep you guys on your toes. And we're going to use this over feature on features, over feature on margins. So over means run it when it's off, run it when it's on. Run it over the values of feature Heinz, which is 0, 1. So it's going to run it when it's on, run it when it's off. What we should get used to doing, and I didn't do, well, I actually do in the beginning, is what we should get used to doing is adding the iDots to all of our dummies. But we're fine now. So let's run our our margins. We're going to get, what were my increments? Yeah, 10%. Yeah, so you can see how we have 121 different prices, but notice 121 occurs twice. One when this is 0, which is our the over variable, which is featured, and one when it's 1. So there's going to be 121 times 2, which is 142 actual margins produced here. So already this is not 140, 242 actual margins outputs. So again, each price over whether or not feature is on or off. And then we can do we can use our margins counts. And there we go. Heinz, and then Heinz when it's on feature. And again, we'll get, there's no reason to run either Logits or Probits. Run one and stick with it. We already saw you're going to get virtually identical results, so there really isn't any reason to run one versus the other. There will be later, when we get into some other models, the computation time is actually going to make a difference. So as a difference as in, we're just going to watch it. Where one's going to run instantaneously, and the other one's going to actually take 5 minutes or so. So bring a beer or something for that. So I'll let you know when we're going to do that.
I run the slow one.
What's that?
I run the slow one and drink my beer.
Yeah, we're gonna do shots and make a game out of it.
Great.
So the way we can measure this is, remember that the results are going to be different at different prices. So it's nonlinear, so we can see how, unlike here where we've measured the distance, the promotional effect as this horizontal difference, with our binaries, we're going to measure it as the vertical distance. So we'll pick a price. Let's see, this looks like 6 cents. Ooh, and that lines up perfect. And it looks like at 6 cents, the probability of purchasing Heinz is 20%. And then I'll go to 5 cents. That's going to go too high. Let's go to 7 cents. We'll go over here. At 7 cents, the probability of purchasing Heinz is something very small. But when it's on promotion, the promotional effect will be at 6 cents, the probability of purchasing Heinz increases to about 0.3. So at a price of 6 cents, the effective promotion is to increase the probability of purchasing Heinz by about 10 percentage points. That's a pretty decent chunk. And again, we're just eyeballing this stuff. Notice that effect is going to be smaller at this tail. At 7 cents, that promotional effect is going to be smaller. This vertical distance is going to be smaller. So it'll increase it from, I don't know, something very small to something a little bit not as small.